Thanks for coming, and thank you, Klaus, for inviting me for this talk. I want today to give you a little bit of a glimpse on what big data and Science 2.0 might have in common in the future, or already have in the development. And so since I'm not coming from a large organization, but from a very tiny one, I want to at least say a few words about it so that you can put me into relation. So on the one hand, I'm professor at the Technical University in Graz, but on the other hand, I'm heading Austria's Research Center for Data-Driven Business and Big Data Analytics. We are there for more than 15 years now. We have about 70 people working with us. Bright young researchers, 2 of them are also here in the room. We are doing a lot of applied research. So that is, we are mainly at the moment working with companies, developing solutions, big data solutions for them specifically. But I don't see really a reason why this wouldn't be also extending for other kinds of organizations which have a lot of data, which I think many of you here have. In addition, we are running a lot of European funded projects. This gives us the space to also explore a little bit more crazy ideas and then trying to turn them into useful, usable systems for our partners. We are lucky that we just got a new funding, so we are funded for the next 8 years. We have a nice basis now to continue. And our goal and our vision is to support and develop Austrian companies into data-driven businesses. And we see this data-driven business as something as a cognitive computing challenge. That means that this challenge is not purely technical, not purely analytical, but it is also has a very, very strong part on the human side. So in order to bring these technologies into use in different organizations, you really have to understand quite a lot about the cognitive backgrounds of people and how they can take information on, how they can learn, how they can actually perceive large amounts of data, and how we can help them to further drill into such data. So this is what we are trying to do at the Know Center, and for this we have 4 focus points. On the one hand, we are looking into knowledge discovery, so this is really the field where you try to dig deep into the data and you try to analyze the content. On the other hand, we are looking into social computing, so these are social networks, and here really the network character, which we've been talking about the last day, is very much in foreground to really understand how people are in contact with each other. Another important point is knowledge visualization. How can we visualize all these huge amounts of data which are out there in a way that people can actually do anything with it? And finally, we look into ubiquitous personal computing, which means that we also want to understand a lot about the user, him or herself, by using sensors such as smartphone sensors to understand in which situation is somebody at a certain moment, in order to then pre-filter information so that it's applicable for his or her task. So it's really context-aware and adaptive computing. So, big data, what is this really? There are lots and lots of definitions out there. The most known one probably is the 3 V's. So it's volume, the sheer size of things, velocity, the speed in which this data is coming in, and variety, the lots of different kinds of data which are out there and which need to somehow be integrated and made sense of. However, I really like the definition by the Oxford Internet Institute, which does not put all these size aspects so much into the forefront, but really looks into what is the difference if we suddenly have more data. It's not necessarily, it doesn't have to be terabytes and petabytes, but if we used to maybe take a sample only once a year in some environments, and we suddenly are able to do this every second, or maybe only every day, then that increases the data itself, but in addition, it really gives us the possibility for much more insights to really understand the working of the environment, the working of human body in much, much more detail. So when you look at the analytics part, so really the technical part, all of this starts with data. You can have the most different varieties of data out there, text, sensor data, linked data, activity traces, whatever, coming in. And those might be either openly available in public, or they might be private in different libraries and different organizations. They might be structured, like taxonomies, ontologies, or they might be unstructured, such as text, which is really hard to understand for the computer. And in addition, and most problematically, they might be very uncertain, and they are changing all the time. So the challenge is to build such an intelligent algorithms, analytics engines, basically, which can take in all these kind of data and process them in a way so that people can actually understand it better. So, but here actually comes in what I'm very happy that Eric already mentioned this very strongly, this human in the loop in all these kind of activities. So it's not, as many people make you believe, the data comes in and magically the big insight comes out. Instead, there is somebody needed who has a lot of domain knowledge. There is somebody who knows a lot about the publications. There is somebody who knows a lot about chemistry or mechanical engineering in order to really interpret and understand the data and the analytics results which are coming out. And this person is really responsible to bringing in his or her knowledge into the analytics to understand, to really identify interesting patterns in the data. Because to find patterns in data, this is just not that hard. We can find lots of patterns, and but they might not mean anything. So we really need to find the things which are interesting and where experts say, yeah, this is an interesting part. And so then it goes on, and hopefully by the end of this process, we have something which we call actionable knowledge. So something which actually is an insight which can be turned into action, which is actually helping some person out there to do his or her work and to solve a problem or a societal challenge. So on the one hand, it can go to users, and there, of course, again, we need a lot of visualization, recommendation, capabilities in order to really bring across the result of the analytics. On the other hand, we can also have all these analytics results feeding in back into the computer or back into the data storages which we have, but then in a more formal way. So this is also what Eric was talking about when he starts building these taxonomies. So coming out of all this big mess of tags, there's a mechanism in creating additional structure on top of this. And this is something which can be fed back into the systems and which can be in future analytics then be used in order to gain more insights out of all of this. Okay, so but this was only the technical or part of all of this. So in order to really bring the power of big data into where I mostly work, businesses, is that you have to understand how to build a data-driven business. And there are nice definitions out there, for example, from LinkedIn. And here the point is that you have business processes which are based on automatic generation, interpretation, and exploitation of these large amounts of data which are out there. And in order to build such a data-driven business, you have to follow 4 very central steps. On the one hand, we have to provide the data as well as an IT infrastructure to really deal with this. So this is also something which Mr. Bergman yesterday talked about, that this is like a basis which we need in order to really interact with the data and to have the tools to really be able to really look at them and to analyze them. But then comes a very difficult point. It means to democratize the data within the company. So that means that we have to make this data available to a lot and lots of people and encourage them to really use it and have as much openness as possible. And then comes another point, enabling the experimentation with that data. So there comes in, again, a lot of the services or expert tools which we can create in order to help people take that data, to find the right data which is out there, to link it together, to start analyzing on it, and maybe and hopefully having some more insights in it. And then the final point, which is the really tough part, is to support a data-driven culture, which means a culture which starts asking intelligent and critical questions, a culture where people say, wait a minute, how was this again? I want to look closer into how many people have a certain tumor, and I'm pretty sure that there is a specific aspect of it. And so you drill into this, you ask more questions, and in order to answering those questions, you might actually have to create new data. You have to look into your processes to see where the data could come from, or if you can acquire it from the outside, and then again, the whole thing starts all over again. So you really have to promote this inquisitive nature, this kind of detective work, which is in science really, to bring it and use the data which is out there in order to answer those questions. So if we now go from data-driven businesses to data-driven science, I think there is not such a large difference. So, of course, we need to not only look at business processes, but research practices and processes, and we have to share all that data not within one organization, but across many organizations within the whole scientific communities. And so I want to give you here a few ideas and a few things we're working on in order to make this happen, specifically targeting on the last 3 points on the slide. So let me start out with looking at publications as big data. So we had a lot of presentations yesterday which showed us how many publications every day, every year are produced. That's not a new phenomenon, actually. This was already noted in 1613 by Barnaby Rich, who noted that it was already becoming impossible to read everything which is coming out there. By now, this definitely is impossible. Even within a limited field, there are no possibilities to really read all of the publications which are coming out there. So now when we look back at the vision of Isaac Newton, who said, okay, let's be standing on the shoulder of giants, of people who have done enormous great work and research. We want to reuse the knowledge which has been done, which has been created out there. So we, how can we do this if we are not even able to read the publications anymore? Instead, what's happening, and I think you all can relate to this, is the reality that we are covered under a pile of paper. And so the most important thing, the first thing, is to get an orientation, to figure out what are we really wanting to look at. So as we had already yesterday, a lot of approaches there. Of course, we can start to generating overviews of publications. So this is an example which we did within the area of technology enhanced learning research community, and there we clustered the publications according to themes. But in that case, it's not themes which come out of the content, but it's coming from the usage of the publications. So if you might know this visualization, it's also running in Mendeley. So we are using there how people are actually storing, or what kind of publications are in their own repositories in Mendeley, and then we can see which ones are always in the same repositories, and we can cluster them according to this usage data, and we can, through this, also see if new bubbles, new topics emerge through the usage and compilation of different kind of sets of publications. Of course, another thing which we've also seen yesterday is to really use the click streams. We can have recommendations which then even go across journal publications, where we can look at clicks where one person has been clicking through different kinds of journals, and then if that person goes first in one journal and then in another, we can see that there are similarities between the things which he or she is looking at, and we can recommend additional publications. So, but that all still doesn't solve our problem that we might not even have the time to read them all. So that's why we started to kind of re-engineer publications, in the sense that we're trying to extract facts, tables, pictures, insights out of papers, out of PDFs, and provide them as linked open data in the linked open data cloud. So basically we're going through a paper such as this, trying to extract the tables, trying to understand as much as possible about the different data which are in there, and also finding certain paragraphs in the document which seem to be the condensation of the main insight, and to provide all of this together with metadata in the linked open data cloud. What then can happen, so basically what we build is a kind of a pipeline. You can put your paper in and then hit data extractor, and it extracts all this. But here again, we need the human again, because that's not a, I mean, it's a nice process. It works to a certain qualitative extent, but of course not 100%. So we need people to look at that, to see if this is really valid, if this makes sense, if the data has been extracted in the right way, to give feedback. And finally, then really to publish it in the linked open data cloud in order to link it to all the other data which is already out there. And finally, of course, we need then tools to reuse this data again, and to also reuse other kind of data which is in the linked open data cloud. And I don't know if you ever tried using a Sparkle query on linked open data. Even for computer scientists, this is not always straightforward. So you really need a tool which helps you to deal with all this cool data which is out there. So we created a little query wizard which enables women to look into all these data which is out there, to look at the different tables, to select the right data, and finally to run analytics and have visualizations such as timelines and categorization algorithms on top, which makes you helps you to understand the data. Okay, let me summarize this. This is the basically turning publications into scientific big data. We use, on the one hand, usage data in order to give a better understanding which publications might be important for me. But on the other hand, I presented things, so we really use the textually encoded knowledge in order to build more formal, more linked open data knowledge, which then hopefully in the future will be able to be processed automatically again. Okay, so but then we still have this point about supporting the data-driven culture. And there we looked at all these different open data platforms out there, and we found that they have great data. However, they are completely unsocial. So it's just data, it's nothing else out there. On the other hand, when we look at the success of the social web, and that's also something which we discussed yesterday quite a lot, it would really make sense to put a social factor somehow with this data together. And so we came up with this idea of socializing the resources as a success factor. And so it would be necessary to enable us to have a discussion around data, to pose questions around data. However, what's very different from the normal social web is that here we are talking about very small groups of people who are really interested in this data. In general, these are small groups of researchers who want to discuss in depth about this, so that we need to have specific services and tools for them to help to do this. So what we decided upon is to create a data flea market. So the idea of the flea market is that there's something, there are small things you have. They all of themselves are not that extremely valuable, but they might become valuable by coming together. And you are willing to also share them or exchange them with other people. So this is why we call this the flea market, and it allows people to ask data-centric questions, to put in their data and say, okay, I have a specific question about this, and I have a specific idea of how this could be done, and then the discussion around the data can happen. In addition, we then have capabilities and analytics in order to really help answer those questions with the data which is there, and maybe also finding other data out there which can help to even shed more light on this. And you have these little buttons with the heart where you can then say, I want to donate this whole insight, this picture, including with the data behind it, in order for other people to use it in the future. You also, of course, have things like bookmarking your resources, and so that you can work on this in the future. We are right now working on an economic sustainability for such a flea market, because, of course, this rests a lot on donations, and it's a customer-to-customer situation. This is interesting. It's not a business-to-customer, so it's really, there are 2 or more researchers out there who want to share stuff, and they want to try to really work together. And so how can we do this? And of course, important things are social reputation models, which we will be looking into in the future much more in detail. Okay, so this was ideas on how we can support data-driven cultures and processes with big data. But let me go one more step back to the idea of having data-driven science. So I think it's important to also look at the scientific processes which are out there. So there, so like as business processes, there are also scientific processes out there, and the most known, of course, is the publication process, where we're all very much involved in. But there are lots and lots of other processes. And in a while back, in an EU project, we did a study where we looked into the different processes, core processes of research, and also then support processes, which what other things do researchers do in order to get their research really going, and management processes, things which help the researcher to really achieve his or her goal, to set strategies, to set goals, and so forth. So I think at the moment we are focusing very strongly only on a very small subset of these process steps in order to support them with all the great tools which we've seen yesterday here already. But I think it would make really sense to look into this. We've tried to basically do a analysis where there are still open issues, which one of those process steps have been covered really well and which ones have not. And it would be nice to get also feedback from you in which of those process steps different kind of support mechanisms would be helpful or not. Okay, and with this I would like to close with a question, since inquisitive questions I think are important. For me, the question, is there something like an open science data value chain? So is there something where we start with open knowledge, we start with the researchers doing their stuff, and then publishing their insights in different venues, open access or with publishers, and then how is this supported by an open infrastructure, open science infrastructure, and how can in the end these insights be used for open innovation and maybe even commercialization. So the question for me is really how is there such a data value chain? And I believe, yes, there is one, and I think we need to encourage players out there to take part in this data value chain. So players such as libraries who have a lot of the data, players such as publishers who have the data and also have quite a lot of access to the users, and also, of course, the researchers themselves. Thank you very much.
I'm always a little concerned. I have a question. If you talk about open science data value chain, one of our main problems in the area I'm working in education, if you're talking about research data or other data, is not the technical problems, or it's the data privacy problems. So all these things are not happening because we have data privacy problems. The data are in principle open for researchers, but you can't work with the different types of data or something like this. You are only allowed to use the data sets you are asking for to do your specific research question. Do you have any experience with
well, the next speaker, I'm sure, will shed much more light on this. Of course, we are looking very much into this. On the one hand, also like on security issues. So how can you, whatever, encrypt data if this is really possible? But also looking into how can we ensure the privacy of people, specifically in medical environments where you have like data of patients, and if you have the genomical data, this is inherently not anonymizable. This is always just one person has that genome, and so of course that there are big problems out there. And I would be very happy if researchers in the domain of law and policy would really take this subject very seriously and help us go forward, because I think this is a big roadblock at the moment.
Okay, thank you. Yes, one question over here.
Thank you very much, Stefanie, for the talk. So all the data you were talking about is like usage data, user data, and there's a lot of data contained in the documents. You referred to the code project with the fact extraction. Mm-hmm. One problem we currently have, and I think that is a limitation to the open science data value chain, is that normally we do not have the right to do text and data mining on the documents. We don't have the license, even if it's an open access document, you don't necessarily have the license to extract the facts. And if it's licensed publications, we as a library only have the license to distribute the entire document, but we don't have a license to do text and data mining. If we can open up that limitation, I think then we can exploit the open science data value chain to its full potential.
I totally agree. Yeah, there's another question back there.
We have two more questions.
Yes, one more. Okay, thank you very much for your interesting talk. But I think this is interesting, your idea of a data value chain. But don't you think you have to differentiate between public research, public use, private research, private use? Because if you want to blend it in one value chain, it becomes quite complicated. In particular, what Klaus was saying, that indeed we might be able to get TDM, to solve the TDM problem for the public part of the research cycle, but probably less easy for the private part of it. So where in your picture do you see, because it boils down to the question, where do you see the kind of the data commons which is underlying the open science idea and the open data idea? So at some point in time we must picture that in as well.
Well, I think we have already at least one example where this sharing of data across different organizations actually works well, and that's the genomic research. So there's a common standard on how to publish the the genome sequences. There's also you have to publish the data when you publish a publication. And so all of that data is really out there, and it's available, and it's worldwide. It has one format so that people can actually use it. I think that was started because there was these incredible amounts of money required in order to get to that data in the first place. And in many cases, or all cases, I don't know, this was funded by public entities. And so there was the handle on it, which really made it possible to, from the start, say, okay, all what comes out there is public. Now with the libraries, you always have the problem that you have also the history, and you cannot ask people retrospectively if it would still be okay to extract their tables out of their papers. So this is of course a problem, but this could also be solved in the future by having people really signing these agreements that also parts of their publications can be used. And I think as long as there's the attribution still to the author, I wouldn't really see why researchers wouldn't jump to it.
One more question.
I just wanted to make a quick point concerning this TDM issues, text and data mining. I think the current agenda is essential for us, that in particular we support the current revision of the EU legislation in this respect, and the text and data mining extension as suggested by the current report by Julia Reda at the European Parliament. I wanted to mention also that we've got a similar agenda in France, typically where we're going to have this Loi du numérique being discussed this year, where we expect to have 2 specific articles concerning open access and text and data mining at the French level. And this is a general push we need to make towards our politics, that they support such changes.
I couldn't agree more. Yeah.